Good day, sir. I'm here to discuss the generated problems in permeability of soil and stresses in soil. First, in number one, the permeability in easy part. The situation in here will be when water flows through the soil under the constant head rate of 58 cubic centimeter per minute between 2 points of 9 centimeter apart. It is discovered to be 21.28 centimeter or centimeters. The cylindrical molds of diameter of 10 centimeter contains a 20 centimeter long of sand. So, we imagine that meron tayong cylindrical. Then, meron siyang sun na yung long na haba niya will be 20 centimeter and the diameter will be 10 centimeter and apart. First thing to do, we calculate the area pi over 4, the diameter squared, and substitute the value of diameter will be 10 centimeter, and we can get 78.54 centimeter squared. Next, compute the hydraulic gradient. We have H over L. The H stands for head loss and L, which is length. Then the head loss will be 21.18 centimeters. Discovered natin na 21 ay yung head loss niya. Halimbawa, yung head loss niya dito. Will be 21.18. Yung length niya na mamumove apart will be 9. So 21.18 divided by 9 is equal to 2.53. Then the rate of flow will be 58 cubic per minute. Dito kasi, sabi dito, work out the centimeter per second of coefficient of permeability. Pero yung ano natin, yung rate of flow natin is naka cubic centimeter per minute. So, para maging per centimeter per second yan, we can divide it into 60 seconds. Diba? In 1 minute, we have 60 seconds. Then, is equal to 58 divided by 60 is equal to 0.967 cubic centimeter per second. So, by computing coefficient of permeability, we can use this formula. The Q is equal to Ki over A. So, substitute the value. We have 0.967 is equal to K, ayun yung coefficient permeability na hinahanap natin, times yung sa hydraulic gradient na 2.53 and multiply natin sa area, which is 78.54. 0.54. So, i-shift solve na lang natin yan. Then, ang makukuha natin will be the coefficient of permeability, 4.87 times 10 raised to negative 3 centimeter per second. Next, proceed to the next problem. In constant laboratory, permeability test on earthy sand. Kung naririnig natin yung word na earthy sand, ano yung napapaisip natin or ano yung tumatakbo sa utak natin when we say earthy sand? Yung earthy sand is ito yung pinong-pinong buhangin na tinatawag. Then, just look in this illustration, we have yung sabi natin na example, ito yung faucet. And it can flow the water in here. The recent pipe we have 80 centimeter long. Hanggang manggagaling siya dito. Bababa down siya dito. And move it here into specimen. We have diameter of specimen will be 10 centimeter, and we have excuse me, we have length of specimen will be 50 centimeter, and proceed in here. Pataas na siya, going up, and flow in here. So, yung ano natin sa standpoint is meron tayong 80. Yung head loss natin, or constant head difference, we have 60. So, yung 80, ima-minus natin yung sa 60, ang matitira na lang is 20 centimeter yung pagbabagsakan ng water sa container natin. So, just repeat the data in here. The length of specimen will be 15 centimeter. The diameter of specimen is equal to 10 centimeter. The void ratio of the specimen will be 0.56. Volume of water collected in 5 minutes. 5 minutes daw. Within 15 minutes. Na yung volume natin, nung tinest ito sa laboratory, yung duration ng time within 5 minutes lang. And na-conduct natin na dito will be 430 cubic centimeter. Then the constant head difference is equal to 60 centimeter. So compute the K, which is the coefficient of permeability, V, the discharge velocity, and Vs stand for seepage of velocity. So first in here, we have coefficient of permeability is equal to Q over L over A times the head loss times time. So substitute the value, we have 430 within 5 minutes. Times the length na 15 na specimen na length natin. Then the area is 5 over 4 times 10 raised to 2 times 60 yung head loss natin. Within 5 minutes, and multiply it to 60 seconds. So we can get 4.562 times 10 raised to negative 3 centimeter per second. Next, our discharge velocity. The formula of this will be discharge of velocity is equal to dito kasi, na ginagamit, meron tayong Q na big letter and Q na small letter. Para di tayo malito, kapag yung Q natin, ayun na maliit, will be the flow rate. And yung Q na big letter naman is, ayun yung volume of water na na-collect natin. So, 430 over pi over 4 times 10 yung diameter raised to 2 times 5 times 60. So, yung makukuha natin is 0.018 centimeters. So, let me check. Double check first. So, we have 430 and pi 4 10 squared, then 5 times 60. Ayun, tama. So, our porosity in here, kasi hindi natin makukuha yung seepage of velocity kapag hindi pa natin nasa-solve tong n. Pero, pwede rin naman na let's just say, i-input na lang natin tong 0.56 over 1 plus 0.56. But, yung ginawa ko is sineparate ko na lang bago ko siya i-compute dito. So, yung n, the formula of porosity will be E over 1 plus E is equal to, and then substitute the value of our void ratio in here. We have 0.56 over 1 plus 0.56 will be 0.359. And then, makukuha na natin yung seepage of velocity. So, meron na tayong discharge of velocity, tapos meron na tayong porosity. So, substitute lang natin yung value dyan. So, we can get the 0.050 centimeter per second. Next. In here, in our illustration, the seepage is occurring through the sandy layer underneath the concrete dam. The concrete dam as shown in our illustration here. So, the data, given data will be upstream water level, we have H1 is equal to 20 meter. Downstream natin is equal to 20 m. And our H2 will be 4.5. And then our H3, we have 0.80. Sorry for my writing. Naka-mouse lang kasi. Wala pa akong ano. And our length will be 50 m. Ayan, yung sa concrete dam na length. Sabi, work out the seepage velocity, quantity of seepage per day, if dam is 430 long, and the rate of seepage per unit length of the dam. So, in step 1, to determine the hydraulic gradient first. So, I is equal to H over L. Our H1, if I'm not mistaken, H1, the upstream, and also downstream, H2. Minus natin siya. Then, over, yung i-substitute natin yung value natin ng concrete dam, we have 50. So, we can get 0.31. And then the porosity is equal to void of ratio over 1 plus E is equal to 0.9 over 1 plus 0.9, yung ano natin, is equal to 0.474. Siyempre, meron na tayong, yan, tama. Tapos yung flow rate is equal to KIA is equal to 0.008, 0.31 times 0.80 times 1. So, yung 0.80 kasi, ayun yung thickness ng sandy layer natin. Thickness niya within here, tapos dito sa imperious rock natin. Dito yung 0.80. Yan. Times 1. Why? But may times 1 tayo dyan? Kasi para ma-convert natin siya into cubic meter. So, bale, ang makukuha natin is 0.14 times 10 raised to negative 2 cubic meter per hour per minute. Yan. Yun yung unit natin sa flow of rate. So, the rate of seepage will be 7.14 times 10 raised to negative 2 cubic meter per hour per minute. So next, determine the seepage of velocity. We have Ki over N. The K is hydraulic conductivity and the velocity, while the I is hydraulic gradient. So substitute the value. We have the K will be 0.008 times 0.31 over 0.474 is equal to 5.23 times 10 raised to negative 3 centimeter per second. Kasi nakaano yun. Next. Sabi niya dito, next. Determine the quantity of seepage per day of the dam of 430. So, ito yung Q natin, yung flow rate, 24. Kasi, within one day, is equivalent to 24 hours. Tama, di ba? Meron tayong 24 hours within one day or a day. Kasi sabi niya a day, wala naman siyang parang like 2 days or ano lang. We have 24 and then i-multiply lang natin siya sa yung per day na 430 meter long na natin dun sa dam. We have and makukuha na natin yung 736.878 cubic meter. Next, here, stress in soil, the support. So, in this situation, or the problem rather, the quantities of the dense layer of soil are as follows. We have given here na mga data na void ratio is equal to 0.50, the effective diameter D sub 10 is equal to 20 micrometer, capillary constant is equal to 0.30, calculate the height of the capillary rise in meter, and what type of soil is this. So yung effective diameter, kasi naka-micrometer siya, i-convert natin siya into centimeter. if I'm not mistaken, i-divide natin siya in 10,000 para makuha natin para ma-convert natin siya into centimeter, yung micrometer. So, makukuha natin is 0.002 centimeter. Next, dito, ang formula ng natin, height of capillary rise in meter will be H is equal to C. C is constant, capillary constant rather, over void ratio, then multiply it to effective diameter. So, substitute the value. We have 0.30 over 0.50 times 0.002. We have 300. 300 centimeter. And divide it into 100 para makuha natin yung height na in meter siya. We have H is equal to 3 meter. So, therefore, the range of capillary rise is between 1.3 to 7.5. So, the type of this soil will be silt. Yung nasa module natin eh. Nasa module natin kung paano natin siya makukuha. Paano siya ma-determine kung anong type ng soil siya na papasok. So here, yung range of capillary rise kapag halimbawa nasa ano siya, sabi natin is nasa 0.1 to 0.02 meter, 0.2 meter, nasa core sand siya. Nasa core sand. And then kapag 0.3 naman to 1.2, nasa fine sand naman siya. Fine sand. Kapag 1.3, kasi in meter yan meter to 7.5 will be silt. And then, sa 7.5 to 23 is clay na siya. Yun lang. Ayan yung magiging notes ko dito. Notes natin. Next. Today's problem. In a stiff saturated clay daw, meron daw siyang moisture na 30% and meron siyang specific gravity na 2.7. An exploratory drill hole has made. You know, ito yung an illustration of excavation drill natin na hole. Parang, next is the sand layer beneath the clay was artesian exertion. Artesian exertion was observed to exist. Water around the drill hole rise 8 meter above the uppermost. Yung 8 meter uppermost, ito. Ibayin natin yung color. Uppermost, ito yung sinasabing uppermost. Ibayin natin yung color. para magandang tingnan. Natin. Ito yung uppermost na tinutukoy dito na nag-rise siya na dun sa drill hole. We have 8 meter above uppermost sand layer. Dito siya. Oh. Pag ganun siya, pa-up siya. Hanggang dito, mabubutas siya dito. Then, if an uncovered excavation, pag sinabing uncovered, ito yung ano siya, open siya. Open. Open yung excavation na finland sa clay. So, sabi dito, we determine the safe excavation depth, yung lalim ng proceeding the bottom heaves ng clay. So, and the explanation in here will be, if open excavation will, kasi sabi niya, ano siya uncover excavation. So, if open excavation will be made in the clay, quicksand condition can occur at some depth where effective stress will be zero. Effective stress will be zero. And then, for our clay, our unit saturation is equal to specific gravity plus void ratio over 1 plus E, multiply the unit weight of water. So, bago natin yan i-solve, let's say, kunin po natin yung void ratio muna. So, alam natin na ang formula nito, para makuha natin, kasi meron na tayong yung saturation, kasi yung S natin will be 1. Equivalent na siya sa 1. Tapos yung given na rin yung water, or I mean moisture ng kalay stiff saturated clay natin na 30%, then we have a specific gravity of 2.7. So ang makukuha natin na void ratio will be 0.18. So yan. Yan. So unit of saturation is equal to yung specific gravity natin, we have 2.7. Tapos may plus yung void ratio over 1 plus yung ano natin dito, yung void ratio natin. Meron tayong void ratio na 0. Oh my gosh. Yung thickness ng pen natin masyadong makapal. Yan. 0.81. Over 1 plus 0.81 din dito. Yan. So, we compute it first. Meron tayong 2.7 plus 0.81, 1 plus 0.81, tayong nakalimutan natin yung unit ng water na 0.9.81 rather. Yan. Sorry sa sulat. 9.81. So, ang makukuha natin is 19.02 kilonewton per cubic meter. Aside from that, suppose that the depth of excavation will be h. Gagawin natin siyang h. So, yung effective stress pa rin natin will be 0 pa rin from that bottom. So, ito yung ito natin, iyan natin. Ito yung na-drill natin. Na-drill natin. Tapos, ito yung height. Ito. We have 15. 15. And our here, kasi sahibs to eh. In clay in bottom, sabi niya. So, tapos dito, yung edge natin. So, yung magiging equation natin dito will be 15 minus h. Yan. Dito kasi, sa effective stress, para makuha natin yung effective stress, or rather, the our h, the excavation, or depth of excavation rather, kailangan natin para makuha natin is effective stress is equal to unit of saturation times the 15 minus h, yung na-form natin na equation in here, minus yung yung drill hole rise in here above uppermost sand layer, sabi niya. Will be 8 times yung unit weight ng water will be 9.81 kasi kn m squared. Cube, I mean. So, is shift solve na lang natin yan. So, 19.02 times 10 minus h equal to 8 times 9.81. Right, 19.02 10 I mean 15 15 here, 15 here. So 15 minus h equals to 8 times 9.81 will be 10.87. Yun. Yan. So, ang makukuha natin 10.87 height meter ng safe excavation depth preceding the bottom heaves in clay. Next, stress in soil, different part, difficult part. So, is na to? Kaya pa? So, in here, meron tayong sand sa first layer, tapos meron tayong groundwater table dito, and we have, next is the clay table, we have water content, we have 33%, and specific gravity is 2.65, ganon din dito sa natin is 2.65 din, and the average void ratio is equal to 0.58. So, unit of saturation natin is equal to specific gravity plus void ratio multiplied by unit weight of water over 1 plus void ratio. So, first thing to do, we solve the void ratio using this formula. The 1 is saturated na siya, 1 times E equals to 43% times 2.65, and our void ratio will be 1.140. 1.140. And then, dito naman, nakalimutan tayo dito na E. Unit saturation, unit of saturation, rather, will be GS plus E multiplied by unit of water over 1 plus E. I-substitute lang natin yung value ng ating, ano natin dito. We'll have 2.65 plus yung nakuha natin na 140 multiplied by 9.81 over 1 plus 1.140. So, double check ko lang if tama yung natin dito. 2.65 plus 1.140 times 9.81. 1 plus 1.140. Yun, tama. 17.37 kilonewton cubic meter. Per cubic meter, rather. In our dry density, or unit weight of dry, so specific gravity multiplied by unit of water over 1 plus E. So, 2.65 times 9.81, ayun yung unit weight ng water natin, 1 plus 0.58, equal to 16.45 kilonewton cubic or per cubic meter. Double check natin. 2.65 times 9.81, 1 plus 0.58, 2.65, tama, 16.45. Next, the dry, say, unit weight saturation. So, yung formula na i-use natin will be GS plus E multiplied by dry unit of water over 1 plus void ratio. So, substitute the value natin dito, yung 10. So, 2.65 times 9.81 over 1 plus 0.58 will be 16.45. Tapos, ganoon din dito. Substitute lang natin dito. 2.65 plus 0.58 times 9.81 over 1 plus 0.58 will be 0.05. Double check natin. 2.65 plus 0.58 times 9.81, 1 plus 0.58. Yun. Tama. And then, kailangan natin, ang hinahanap natin is yung total stress niya at depth of 10 meters below ground. Below the ground. Ito yung surface natin, tapos ito yung ground natin. And then 10 meters siya. So, excuse me. So 16.45 multiply natin dito sa ano na sa kanya sabi natin yung height niya dito na 2 plus yung 20.05 na unit weight saturation tapos i-multiply natin dito sa 3 sa 3. Tapos ipa-plus lang natin ng 17.37 yung nakuha natin na dry or unit weight saturation rather na 17.37 cubic meter. I-multiply natin sa 5. Kasi nga 10 meter, di ba? Kaya lahat yan masasakop niya. Is equal to double check natin kung 16.45 2 plus 20.05 times 3 plus 17.37 times 5. Tama. 179.9 kilopascal. So, yung effective stress naman, ito yung pag-effect, yung symbol ng total stress natin will be ganito lang siya. Ganyan. While the effective stress naman, ganito. Tapos, mayroon siyang parang kuwit na ganyan. Sabi pag-uwit na ganyan. Tapos, total stress, yun. Tapos, i-deduct natin siya sa pore stress natin na 8. So, 179 then 179.9 minus 9.81 times 8 is equal to 101.42 kilopascal. That's it. Okay na siya. I will stop it na.